Good morning, everyone. Welcome and thanks for joining our webcast today. This is Jeff Hopper, the Director of Client Services at LumenVox. My team will be presenting the material this morning for you. We want to thank you for signing up and taking time out of your busy day to attend. And we just wanted to give you an opportunity to know what's new in our 11.0 release. We've made some significant enhancements and changes to the product that fulfill a number of requests we've had from customers and partners in our delivery channel. We have, as of this morning, made the products available for download on our website. The new TTS Voices that we've introduced have been added to our web store, and all of the 11.0 release notes and help information is live in our knowledge base at www.lumenvox.com. So with that, let me get us started here. I'll tell you that we have Stephen Keller from our professional services team, Nigel Clinton from the development organization, Matt Warshall from tech support, and myself online during the webcast. We'll be able to address questions and in the chat windows and help moderate the process. Also, Dave Rich, our CEO, is in attendance. If you have anything you'd like to pass along to him, feel free to also put that in the question pane when we bring that up. And this morning I'm going to have Stephen Keller, our solutions architect, actually walk through the technical details of the presentation. We'll try and take about half of the time we have allotted to actually show you the material, and then we'll leave some time open for Q&A. We're going to conduct the Q&A through our online text windows that are part of the GoToWebinar process, and then we will answer those verbally through the speakers, and anything that we can't address verbally, we will send out an FAQ document afterwards with all the additional information. Stephen's going to actually walk through all of the detailed changes and enhancements and things, and then we'll follow up with a short survey at the end of the process. And with that, I think we're ready to begin, so I'm going to actually let Stephen take over and begin the presentation. Again, thanks very much for being here with us this morning.
Great. Good morning or good afternoon, depending on where you are. As Jeff said, I am Stephen Keller. I'm a solutions architect here at LumenVox. Probably most people online here have talked to me before, so I'm not going to spend a ton of time introducing people. I'm just going to go through the quick agenda, and our real purpose here is to be pretty short. We hope to not be particularly wordy or verbose, so we're going to just do a brief introduction, run through some of the big new features that are in 11.0, and hopefully spend whatever time remains doing questions and answers. So if you've got questions, that's great. Just go ahead and, like we said before, there's a questions tab or a little control panel in the GoToWebinar set of tools. You can go and use that to ask us questions. And we will go through the big new features. So sort of the big four ones we want to address. We can talk about anything else you guys are interested in. Our support for precompiled grammars, which is something people have been asking for quite a while, as well as the secure context mode that we've just added, which allows you to suppress any kind of private or confidential information. This is a pretty big change as well, really useful for a lot of our customers who had asked for it. Also, we're going to talk about a bit of a change to the way public rules and grammars work. That's a little more technical. We'll get to it when we get to there. And then talk about we've got a whole bunch of new text-to-speech voices. That's probably one of the big changes. So we'll go through all of those in a little bit of detail and then leave time for questions. So yeah, we're basically going to be talking about the changes in 11.0. We do kind of assume, and I think most people who've signed up are pretty technical, so that's good, because we really do. This is sort of for existing customers, obviously, or people that have some familiarity with our software and speech recognition in general. So we're really going to be talking about what's new and what's changed. And likewise, we're going to be really going through the stuff that's changed from the previous release, which was version 10.5. We've gone over who all is on the line, so if you have any questions from these people, feel free to use the questions tab to ask. And then just a note about the LumenVox release schedule, because obviously we come out with releases on a fairly frequent basis. We release what we call major upgrades 2 to 4 times per year, so that's where we'll increment one of the major or minor version numbers, so going from 10.4 to 10.5. And then now this is a major increase from 10.5 to 11.0. So this is the start of the 11.0 series. We've had 10.0 for about a year and a half now. The 10 series, the 11 series has a number of pretty big changes. And just as always, we always keep our full release notes online. LumenVox.com/help takes you to our knowledge base. And I don't know if you haven't looked at our knowledge base in a little while. It's been updated quite a bit, both for this release and just in general. So if you haven't seen it in a while, it's got a new look to it. It's got some new features. You can ask questions and rate articles and some other cool stuff. And we did mention before, please ask us questions if you have them. Use the question feature, and we'll try to keep track of them all. And we've got Matt Warshall running traffic there, and he'll forward them to the appropriate people. So we've got technical and business resources on the line. Happy to answer anything you guys have. All right, so let's get to what everyone really cares about, which is the new features in LumenVox 11.0. And probably one of the coolest things I'm most excited about, as someone who helps build applications with LumenVox, is this new precompiled grammar feature, which is something that people have been pretty excited for. So just a quick thing, if you're not familiar with the whole notion of grammar compilation, this is something that's always happened. So you've got a plain text or an XML, SRGS grammar of some sort that you need the recognizer to use. And there's a process where we have to turn that from this text or XML file into a compiled binary file. And most of the time that happens pretty seamlessly. If you're loading a small grammar, it happens in a matter of milliseconds. So it's completely unnoticeable. But if you've ever built a larger or more complicated application, you know that it can take a while to load really big grammars, because that compilation process just takes a while. So a neat feature that we've added is the ability to compile your grammars offline and then load them so that callers don't experience a delay during that compilation process. So for instance, you could compile a grammar in the middle of the night when no one's going to notice, and then just load the new grammar that day. Kind of save some steps and save some times. It also allows you to do something interesting, which is if you're writing grammars for your end users, and for instance, you want to protect the intellectual property that is that grammar. Let's say you've got some sort of interesting secret sauce in your grammar building. By distributing a binary grammar file that's already been compiled, your customers can't actually see what's inside of there. So that is, obviously if you've got a plain text or XML, SRGS grammar, they can kind of see the contents of it. So distributing a binary file to them kind of obfuscates its contents. So the way that we're going to allow you to do pre-compiled grammars is with a grammar compilation tool. So this is actually something we had before, the grammar loader. Previously what it did was take a grammar file and sort of preload it on a number of ASRs. It still does that as well, but now it also can go ahead and actually output a compiled grammar that you can then just load as normal. So we've got here the usage and where it's going to live on both Windows and on Linux. So basically the way that you do it is you'll invoke the grammar loader, give it the path to the grammar file on disk that you want to get, give it the IP address of the ASR server. You can have an optional timeout, and then do -O and the output file name. So if you don't specify an output file, I'll just go ahead and generate one for you. And the speech tuner, if you're familiar with that, it's our Windows-based GUI tool to do all kinds of cool grammar editing stuff. It also has an option to save any grammar you're working on in that interface as a compiled grammar. In terms of loading them, so that's pretty important. You've got your compiled grammar. You now want to actually get it loaded. They're basically treated like any other grammar. So what you do in order to load one is to specify just the path or the URI to the compiled grammar file. So previously you would have given us a URI to an SRGS grammar. Now you can do that, or give us a URI to a precompiled binary grammar. So if you're using MRCP, you should pass us the URI. One note is, this does make sense, but you're not going to try and load a grammar inline over an MRCP message. You want to pass the URI. So depending on which voice platform you're using, most voice platforms will just hand us the URI. Some might go ahead and try and fetch it and pass it to us, but that's not usually the case. Just an important note, if you've written your own MRCP implementation, you want to make sure that if you're going to load binary grammars, you don't try to send binary contents in line over the MRCP channel. And if you're using our C or C++ APIs, they'll just call load grammar like you would normally, and it should work pretty well. Just, again, you're not going to actually use load grammar from buffer to try and read and stream in the actual binary contents of the thing. So here's one important note, which is we almost always try to maintain backwards compatibility. So obviously, if you've got a grammar that worked in a previous version of our software, we always want to try and make sure that it works in the future version of the software. However, we're not necessarily going to guarantee that compiled grammars are going to work from version to version. We'll make our best effort to, but binary formats, sometimes we need to make some changes. So if obviously 11.0 is the first version to support binary grammars, but if you, say, move from 11.0 to 11.1 in the future, our strong recommendation is that you recompile any binary grammars. And then in terms of, there's a little bit of complexity in terms of referencing grammars. Obviously, one of the features of writing grammars is you can reference rules or just sort of implicit root rules in other grammar files. So when you compile a grammar, if it has references to any other grammars, all those other grammars are going to get pulled in and compiled as part of the big binary file. So I've got a little example here. If you've got grammar A and it references rules in grammar B and grammar C, then the compiled output of that will actually include grammars A, B, and C, which is good, but it does mean that if you expect, like, say, the contents of grammar C to be dynamic, this isn't going to work for that case, right? Because at compilation time, we're going to take everything that's in grammar C and build it into this big binary file that we have. And likewise, you can't, from a non-compiled grammar, reference a compiled grammar. So you can't do this kind of an SRGS rule where you have a reference to some binary grammar. Hopefully that's pretty straightforward. If you have any questions, again, please ask them. I see a couple of questions going through the questions pane, so that's great. There is also another little bit of a trick when using compiled grammars because it's going to affect speech tuning. Obviously, an important part of tuning an application is looking at its grammars, but part of the point of using compiled grammars is so that you can give out these binary files to end users without them being able to see the source. So this obviously means that when you're doing speech tuning, you can't see the source of a compiled grammar. So if you've got response files, those call SRE files that you load into our speech tuner, you'll be able to listen to the audio and see the decodes like normal, but any compiled grammars that were in there, you'll just see that, oh, this was a compiled grammar, it had this name, but you won't actually be able to edit it or view its contents. You can still actually load the compiled grammar and run tests with them. So you can say, if I put this phrase in against this compiled grammar, what would my output be? But again, you can't actually look at the source, and you can't use the grammar editor to make changes to a compiled grammar. Okay, so that was the compiled grammars thing. A little bit of complexity there, so if you have any questions, feel free to ask. I'm going to move on to one of the other big changes here, and this is another feature that a lot of people have been asking for, and it's really useful for a number of different reasons. And we're calling it our secure context mode. And the reason for this is there's a number of interactions that you do with users in speech applications where you're asking for some kind of sensitive information. So a classic example would be if you're getting a social security number or a credit card number, you probably don't want to write out that number to a log file where just anyone who has access to the logs on that system can read it. This is especially important if you're complying with things like PCI or HIPAA or any of the other privacy guidelines, elsewhere in the world. A lot of times, the really big important things in those privacy guidelines are around what data gets written where, who has access to it, that kind of stuff. So one of the safest things to do is just to do what we're calling suppress those kinds of interactions. The idea being if you've got some kind of sensitive or confidential information that's either being spoken by the text-to-speech server or being decoded by the automatic speech recognizer, you can go ahead and just hide that information so it doesn't actually appear in the log files. So you can actually kind of toggle this secure context on and off for any given interaction or change the default behavior as well. So if you've got some extremely sensitive information or extremely sensitive application where you don't want any of the syntheses or recognitions being logged out, you can go ahead and do that. So there's kind of three different ways to toggle secure context on and off. If you're using MRCP and MRCP with like VoiceXML or something, we have a vendor-specific parameter called com.lumenvox.secureContext, or that affects the ASR. To affect the TTS, you do com.lumenvox.tts.secureContext. And you're going to just set it to a value of either 1 or 0. 1 obviously turns it on, 0 turns it off. So, look at this. I got a note to myself. Sorry, guys. Anyway, in the API, there's a setPropertyEx call to change a value called PropEx secure context, and you'll set that to either 1 or 0. And as you can see, I did not get the exact property name, shame on me, out of media server or client property, but they're basically, I think they're called actually LumenVox, or they're called secure_context and TTS.secure_context, just like they are over MRCP. So basically just go ahead and set these to 1 or 0. And once you've done that, you've actually gone ahead and toggle it on or off. So there's kind of one big thing that it does, well, I guess 2 things that it does, and that's going to be in both the text logs and the call array response utterance files for the tuner. It's going to change the behavior so that the actual sensitive information, that is whatever was spoken by the TTS or whatever was spoken to the ASR, will be replaced with _suppressed. So basically that means that going through the logs, you won't be able to see either what the input from the caller was or what the output from the TTS was. And the same is going to be true with the tuner files, right? Because when you load up call array files in the tuner, you will normally be able to see what was recognized or what the text was spoken, and you won't. It's also going to suppress the audio as well that's captured in those tuner logs. So obviously, if you're going to be doing tuning on secure context applications, your life gets a little bit more complicated because you really can't tune a dialog state that's marked as secure, which is sort of the point of the secure context mode. So, our suggestion would be if you're building these kinds of applications, obviously during testing or tuning, you want to make sure you don't have secure context turned on. Then when you deploy it and have actual sensitive data, you need to go ahead and enable it. And yeah, I'm just getting confirmation here from Nigel that the client property config file name is secure_context, and it's in 2 separate sections for both the ASR and the TTS. So we'll make sure to get that. We'll shoot an email afterwards and have that errata in there, and it's all in the help documentation as well. That's now live. Actually, one more thing I want to say on secure context. I just want to be clear on how it works. So the configuration files are going to control the default behavior. So obviously, if you change it in the configuration files, then sort of all interactions will be secure. So if you turn it on in the config file, all interactions of that type will be suppressed. If you use the API or the MRCP VXML custom headers, in that case, you can toggle it on and off per interaction. So we expect that most applications will run with secure context disabled in the configuration files, and then they will go ahead and turn them basically when you have a sensitive interaction. So let's say you're running a voice XML application. Okay, this form here collects credit card numbers. So when I enter this form, I'm going to set a specific property. I'm going to set that in that secure context vendor-specific property and say, all right, go ahead and make this one sensitive and make this one not sensitive. So that's probably the normal way of doing things. But you can, again, go ahead and turn it on or off globally. All right. Next major change here. This is something that actually kind of affected. We did this in 10.5, and we're actually kind of backing it out for 11.0, that we're making it configurable. This takes a little bit of explanation as to what's going on. So in 10.5, the default behavior of the ASR was modified. And it was done actually to be more in compliance with some SRGS compliance tests. It's kind of a weird sticky point in the spec in terms of exactly how external grammars should be referenced and what rules should be visible. But basically what happened was we said if you reference an external grammar, any public rule in that grammar should be active, even if you're not explicitly referencing that grammar by the root rule. So again, without getting too deep into an SRGS tutorial here, there's a notion that every grammar can be, public or private, and active rules mean rules that can be matched and return something. So the kind of way that electro write grammars is they might make a couple of grammars that have lots of different rules, and then kind of reference those rules explicitly and say, okay, I want, for this decode, I'm going to use a grammar that just references rules A, C, and D, and for this next decode, I'm going to use a grammar that just references B and E and F, and Basically, the idea is any grammar that references another grammar's rule can only reference rules that are public. So there's this notion of public and private scoping. Anyway, in 10.5, we made a change so that any public rule was active, which means it could be matched by the ASR. And this led to some sort of unexpected, unintended behavior for some users who had public rules that they didn't wish to have active. So kind of what you would see is that you would go ahead and run a decode, and you would be matching rules that you thought were not active because you weren't referencing them anywhere. So that was potentially a problem. So what we've done in 11.0 is we made two changes. One is we turned the behavior back to the way it worked in 10.4 and previous, so that default rules must be explicitly referenced in order to be matched. So just because a rule is public doesn't mean it's going to be active during a decode unless there is some reference to it through the root expansion. And we've also added a public rule activation mode in the SRE server config file. So basically, this lets you turn it on by setting it to 1 or turning it off by setting it to 0. So 1 is sort of probably the more compliant mode, but we've really found that I think most users sort of prefer the default off. So and this is something that I don't think that many people noticed, but the people who did notice it, certainly it caused them a little bit of heartburn. So we've gone ahead and made this change to hopefully make things easier and to be backwards compatible with previous LumenVox releases. And whenever possible, it's a good idea to have these things be configurable so everyone can be happy. That's kind of a goal that we're always moving toward. All right, the other big change is, look at this. This is the list of new TTS voices that are in LumenVox 11.0. So lots of new stuff. Got a number of new US English, UK English, Australian English voices. So those are existing languages we already supported, but hey, here's some new voices. Give you a little more variety when building out those applications. Then I actually added a bunch of voices for languages we didn't support before. Danish, Dutch, Italian, Canadian French, Brazilian Portuguese. That's probably been one of the most requested languages. That seems to be a really growing market for IVR. Polish, Romanian, and Icelandic. So as you can see, we're kind of always working to improve our offerings in both TTS and ASR in terms of acoustic models for ASR and voices and languages for TTS. So these will all actually be live if you want to go listen to them on our website. I think maybe a little bit later today that all the new demo stuff is going to be put up to date. So you'll be able to go and play with it and hear what they all sound like and waste an hour or two running funny text through the TTS, which is something I tend to find myself doing from time to time. We've also changed how TTS Voice Selection works, and this is something that's making me very happy as someone who has to answer questions for people about how it works. So basically, if you're familiar with our TTS server, there's kind of there's a number of variables. I guess there's really kind of 4 factors that determine which voice you get when you do a synthesis request. So kind of the first thing is whether or not you're using TTS1 or TTS2. Some of you may know we have kind of 2 different code bases that we use for the TTS stuff. So all these new voices, by the way, are TTS1 voices. The sort of legacy TTS2 stuff is relatively static. But kind of the first decision for synthesis is which TTS family am I in, then which language. Is it US English? Is it British English? Is it Dutch? What's the language? Then gender, is it male or female? And then what is the actual name of the voice? So what gets confusing, if you supply all of these, you say, I want to use this voice in this gender in this language on TTS1, there's no question. It will give you that. What becomes difficult is when you just have some of them. Like let's say you've only specified a language. It has to pick which one it has based on what licenses it has and what packages are installed. So the way that it works is, it's important to understand because you can do a couple of things. Like you could assign nonsense. You could give it a language that doesn't exist or something, right? How does it resolve that? So the most important thing that it looks at is the TTS family. And if you don't specify a TTS family either implicitly by just sort of saying, oh, I want this name and it's in this TTS family. If you give us, we go back up. If you give us Leah, then we know for a fact you want TTS1 because Leah is a TTS1 voice, and we'll make that implicit. Or you can be explicit. You can say, I'm using TTS1, and then we'll go, okay. So once we've made that decision, we have to make another decision, which is which voice from that family to give you. So here's our order of priority. First, If you give us a voice name, we'll use that one if we can. Then we'll use, if we have a language, we'll use that, and then a gender. So let's say you specified Lindsay, which is a U.S. English female voice, but if you were to say the gender is male, you would actually get Lindsay because the voice name is going to take precedence over the gender, right? It's higher on this list. You can think of this sort of as a hierarchical order of priorities. If you specify just English with no country or region identifier, then we'll use this order because there's also kind of confusing within a language, there's these dialects, right? So our preference, and maybe it's just because we're a bunch of Yanks. Well, I guess Nigel's, he's English. I guess he's just being a trader. We'll choose U.S. English first, then British English, and then Australian English. You know, really no nothing meant here other than just sort of frequency of use, I think. That just so happen to be more Americans than Brits. For Spanish, we'll pick Castilian Spanish, and then North American Spanish, and then Latin American Spanish. And for French, we'll choose European French and then Canadian French. So obviously, you can always be explicit and give us the exact language and region you want. So ES-US will always get you what you want. But it's if you just give us a language without giving us the regional dialect, we'll have to make some kind of disambiguation decision. Then there's also basically within a TTS family, if we don't have any other information, the voices actually have a hierarchical kind of order to them. So I'm not going to show it all here, but it's available online. Let me just go ahead and click this link real quick. And if I just bring this browser window over here, you know, you can see it's a pretty long. So this is if you give us no information other than a TTS family. We'll go ahead and use this to pick. I don't know if you guys can blow this up a little bit. I don't know if you can see it. But it's obviously a big, long list. I mean, most of the time it shouldn't come up. I doubt most customers have 40 voices installed and need to figure out whether or not they're going to get, you know, Molly or Margot. But there you go. If you don't give us other information, that's how we'll pick. What's important is that these rules are all now codified and easily explainable. In previous releases, they were not always that easily explained. So there was a little bit more just kind of, I don't want to say randomly, but it made decisions that were not always easy to explain to people. Now it's nice, straightforward, simple, and all well documented. All right, so that is the end of my rambling. Let's go ahead and talk a little bit about some of the questions we've got here. So I believe we have, I see a number of questions here. And Matt has been working on assigning some of these. So let's see here. I'm going to go ahead and unmute Nigel Quinnen. He is our CIO and the leader of our development efforts here. So Nigel, do you want to actually, you've got yourself muted.
There we go. Good morning and afternoon, everybody.
So I'm just going to go through some of these questions here that Matt's given to us. Wants to know, we've got a question from somebody who would like to know if the precompiled grammar format, is there any kind of performance impact when we compile from sRGS to compiled grammar format beyond a size limit, and are there any limits for compiled grammars?
Interesting question. So the precompiled grammar format that we use is actually the same format that we have used, or sorry, it's a very similar format than we have used for some time internally within the engine. So in terms of limitations, it really is the same kind of limitations that we've had within the real product for some considerable time. And as you know, many of the folks that are online here know, we've actually put a lot of time and energy into our grammar processing over the years. So the limitations are few, and obviously we can do some fairly large and fairly complex grammars. So to answer the question, yep, you can take either ABNF, GRXML grammars and compile those into precompiled format and use those as you generally would. Yeah.
Yep, and then a kind of similar question we had was, can precompiled grammars be preloaded during the ASR initialization, so at ASR startup? And we used to have that kind of grammar cache feature. That's always sort of recommended people get around this. How is this affected by the compiled grammars?
Indeed. We could do that. We've actually considered adding that feature into the system. However, the way that we cache grammars in general is we do it in a fairly efficient way. So we will cache grammars in memory, and there are some configuration settings for the SRE that are available for determining how many grammars and the amount of memory of those grammars that can be kept track of in memory at any given time. When these cached grammars are moved out of memory, we always store them to disk. And the good aspect of our grammar caching is that we store these grammars in this precompiled format, this binary format, on disk, so that it can be very rapidly used again in future. So is there any benefit in using a precompiled versus non-precompiled in that caching mechanism? They're basically treat the same, because ultimately any grammar that is presented to the ASR will be converted into this binary format and used directly. So whether it's SRGS that's presented or whether it's a precompiled binary format, they're both treat exactly the same. I think there was an additional question that came in, which was, are there any performance benefits related to precompiled grammars? And I think Stephen kind of touched on this, but maybe we should clarify a little bit. The performance benefits themselves are you skip the pre-compilation, the compilation process if you pre-compile these grammars. Let's say, for example, you have a very complex grammar, and it takes a few seconds for our grammar processor to deal with that, to parse it, check it for correctness, and convert it into this binary format. On some systems, or if it's a large production system and you have a lot of traffic coming through, you may not actually want the CPU and memory hit of that compilation to affect or potentially affect ongoing calls. So you can use the precompiled format, and that can actually be done on an offline machine, so it doesn't have to be your production machine, and then you can move this binary format file to wherever you want, whether it's an HTTP server or over to the ASR itself. So you can use it in that format, and that way the performance, when somebody actually wants to use it from a VXML or whatever, the precompiled grammar is instantly available.
Great. So yeah, I mean, it's I think a couple of different reasons, right? Let me just make sure I reiterate here, because it's a little confusing to me. So we'll make sure it's crystal clear for everyone in attendance. The compiled grammar versus caching is really kind of a convenience thing, right? We've always sort of supported this ability to preload grammars by having them in the grammar cache and then reference the plain text version of them. But I think some people said, it was a little bit extra step to have to do this preload on all your ASRs and kind of introduce this management step. Now you can just precompile the grammar, reference that compiled grammar right within a Voice XML document or however you're writing your applications. And so it's the same performance benefits as the old just pre-cache it and start the ASR, but a little more convenience, and you can move these grammars around pretty easily and reference them. Is that right?
That's exactly it. We've tried to make it very flexible, and as you mentioned, we have been doing this process behind the scenes for the longest time, and we've now basically expanded that and presented that to users, which should be very beneficial to some users.
Yep, great. So hopefully that answered people's questions about that grammar compilation. Please, if you have more, feel free to ask them. I'm going to move on. The next question we had was around secure context. So I guess this is a question about what happens to the utterance recordings that are required by the Voice XML client, like that you might use for recognition again. And I guess really probably there's two pieces of this, right, Nigel? There's what we call our call SRE or our utterance or response file recordings that are used for the speech tuner. And then there's also the recordings that you can get, the sort of waveform that you can ask in Voice XML to get saved off to disk. So can you kind of address those two pieces?
Absolutely. So let's deal with the save waveform first. There's a mechanism within MRCP which allows you to save off the audio from a recognition during the process of receiving this audio. So we fully implement that, and we support that mechanism. That has its own flag. We kind of considered, should we have the secure context mechanism override that, or should we leave the saving and recording of that WAV file under the user's control? Certainly there are global settings for the recording of those WAV files, and those global recordings are normally set such that the files themselves are not recorded. You've got to go in and explicitly set that up. And even after you have set it up, you've then got to explicitly request that the interaction is saved off to that WAV format. So rather than mess with the setting that already exists there for enabling or disabling the saving of that WAV file, we left that completely independent from the secure context. It is something that we considered, but we found it to be more flexible for users to be able to set those independently. So that is something, certainly if you're implementing this at the application level, you should certainly disable both of those at the same time. Now, as to the saving of the recordings and the audio in our call SRE files or tuning files, yes, when secure context is set to 1, so when secure context is enabled through a variety of different means, there's actually 3 ways to enable it: through the config file, through one of the settings, and there's actually the 2 settings that can control that. If it's enabled, the mechanism will actually prevent the saving of those audios to the call SRE file. So, and it will actually suppress a whole bunch of additional information. There are tuning information in there that tells us specifically how the decode went, the kinds of, essentially the parse trees that are associated with the decode. All of that kind of information is entirely suppressed, so it's not saved at all within the call SRE file. It's also important to point out that because we have these 2 different flags, one for ASR and one for TTS, we suppress both of those if they are set. Obviously, those 2 are independent, so if you want to suppress everything, you've got to set it for both your ASR side of things and also your TTS side of things. Clearly, if you think about it from the example that Stephen gave earlier, if you've got a credit card information, clearly you don't want the decode of the credit cards to go to either the log files on disk or the call SRE files. And by the same token, you don't want, let's say the application inadvertently reads it back. Did you say your credit card number was? Clearly, you don't want that TTS information to be stored either. So in both cases, there would be a suppressed logging information, and that's what would appear in the tuner. And no audio is saved in either case as well.
Great. Another quick follow-up, just actually getting back to the pre-compiled grammars. Want to make sure that you can also use pre-compiled grammars local on the same machine as the speech recognition engine. That's correct, right?
That is correct. We've made it so you can reference pre-compiled grammars in exactly the same way as you can any other grammar. So you can reference it from a file-based reference or from a URI which is referencing, say, an HTTP server on a different machine. It treats them both the same.
Great. And I was going to another question about TTS, and this goes to our TTS language families, TTS 1 and TTS 2. And the question is whether or not they can be used simultaneously, like use a TTS 1 male voice and a TTS 2 female voice at the same time. And I think I know the answer to this, right? But the answer is it's kind of, you can, but within a single synthesis request, you need to pick just one language family. So you can certainly have, for instance, you've got lots of different callers online at the same time. You can be speaking different TTS families to different callers, no problem. But within a single SSML document or a single synthesis request, you stick within a single language family. Is that correct?
That is correct. As you mentioned earlier on, we've got the 2 different code bases, and although we try to make them play nicely together, they don't always. And within a single TTS synthesis, you can imagine the difficulty of jumping from one of these engines over to the other engine if you wanted to, say, change languages or change voices partway through. It's problematic, and we basically don't support it. But if you wanted to break that up into, say, 3 syntheses, so you just synthesize the first portion with voice A, second one with voice B from potentially a different TTS engine, and then portion C would be from the first voice, that would work just fine.
Yeah, and I guess it's important, within a single synthesis request or single SSML document, you can switch between voices within a language family. So you can switch from TTS1 male to TTS1 female, no problem. It's just switching language families, kind of a little bit of a chasm there. And also, I think to what Nigel said, making multiple syntheses requests is actually very straightforward. Most syntheses take, again, 10 milliseconds, is that? So it's not like just breaking it up into a few different syntheses is at all problematic. If I needed to play almost uninterrupted audio from TTS1 and then immediately follow into TTS2, that's pretty straightforward, not hard to do, and it sounds really seamless because the amount of time it takes you to listen to a word being spoken is the amount of time to do several syntheses if you needed to. So it's not hard to do a bunch of them and then queue them up and play them out simultaneously, or not simultaneously, but serially with no noticeable gaps to the caller. All right, got another question about a license change from 10.5 to 11.0, and I think I can answer that one. It's pretty straightforward. The licensing is more or less the same as it's always been. The one caveat is, as always, you will need a software maintenance, current software maintenance contract. So you'll make sure that the maintenance date on all of your licenses is today's date. Today being the release date of 11.0. If you try to use 11.0 with licenses that have older dates, you will get errors telling you that that license is not authorized to use this version. But it's just a matter of going into the web portal and renewing the maintenance contract on the licenses, or calling your account representative and getting that straightened out. All right. I'm not seeing any other questions. Does anyone have anything else? Or we can always finish a little early if that works out for people. And just to let everyone know, we will be sending out a link to a recording of this, and I can also send out the presentation to everyone so you guys can have a copy of this. And again, the release notes are all online and go through. We just picked out a few of the big changes in 11.0 to talk about. There's lots and lots of other nice little enhancements and fixes and improvements that make it a really great piece of software that we're very proud of.
And I'll second what Stephen said. We would encourage you to go to the release notes and see the full details. There are a number of pages of the list of items there that are smaller but still part of the release process. And I guess with that, we will thank everyone for attending today.
We did just get one more question there, Jeff, not to interrupt you. But
no, go right ahead.
Questions about loading compiled grammars using the grammar editor, which is part of the LumenVox Speech Tuner. And so the way that works is basically you can load a compiled grammar, and you can use the grammar editor's features to do text parses, right? That's where you type a phrase into the grammar editor and you hit parse, and you can kind of see what both the parse tree and the semantic interpretation would be for that utterance. So that still works. What you can't do, though, is open a compiled grammar and edit it with the grammar editor, because again, part of the design of compiled grammars is to prevent people who have just the binary file from seeing its contents. So that would be a pretty big loophole if we allowed it.
And just to further that thought as well, one of the changes that we put in place for 11.0 was something that has been requested in the past. Clearly, from the ASR's perspective, you can load grammars from URI, and you've been able to do that for quite a long time. But within the speech tuner, you have always had to select the file. So using obviously the Windows file open dialog to browse to and find the grammar file that you're trying to open. So as has been requested many times, we have implemented a new mechanism where you can actually specify the URI to go fetch the grammar from. If that's a different machine, you can do that directly from within the tuner now. So that applies to both SRGS and precompiled grammars. And as Stephen mentioned, you can, if the grammar that you're specifying is SRGS, you'll see the content of the grammar, so you'll be able to edit the grammar within the grammar editor itself in the tuner. And also, if it's a precompiled grammar, you'll get a message saying, hey, this is a precompiled grammar. You won't see the contents, but as Stephen mentioned, you can still run syntheses and interpretations against that grammar within the grammar editor.
All right. Well, I guess that's the end of the questions. I'm not seeing any more. So, Jeff, did you want to go ahead and take us home?
Sure. Let me unmute there. We're going to push out a survey as a final item in the process for today. We'd like your feedback about the usefulness of this format and material. And we also are considering having some follow-on webcasts that are a little bit deeper dive on some of the individual technical topics. And one of the survey questions specifically asks you for your input about that. A, are there topics you'd like to see covered in greater detail or illustrated? And B, if so, which ones and what are you interested in finding out about? We'd like to continue doing these kinds of webcast or presentations for our technical audience so that we can have a little more active dialogue on an ongoing basis with you. So your feedback would be graciously appreciated in that process. Stephen's got up the note right now with the link to the knowledge base for the release notes, so you can refer to that. And with that, I think we are now probably concluded. Stephen, if you'll go ahead and push that survey out for us. Again, thanks very much. If you have any follow-up questions, you can reach us in our usual means at support@LumenVox, or call our phone number and ask for support. Thanks very much. We appreciate your time, and have a great day.